Right, here is the video I promised you on plotting curve graphs. The example that I'm going to do hopefully won't be that tricky, but as I say, it's going to be a really kind of key sort of example for what's going to happen next. So, say that I wanted to plot this graph. I want to plot y is equal to 3 times x squared. So what that means, again, just to remind you, is I want to plot all the points where if I've got an x coordinate, if I square it and I multiply by 3, I get the y coordinate back. So it's basically a formula so that if I put an x coordinate in, I can generate the y coordinate and I can draw this on the graph. So, when you draw a straight line graph, you normally just draw a couple of points, maybe 3 points just to check. When you've got a curved graph, if you imagine, you might need lots of points. So, I mean, this won't be that complicated, but you can imagine if you had some kind of curved graph, you might need an awful lot of points the whole way along to try and work out what that graph is doing. Now, we're not going to have graphs this complicated, well, at least not yet, but we do need more than just 2 or 3 points. Usually in the book, or in my worksheet, I'll tell you what values to put in. If you're not told, you've just got to put in enough. You've got to choose enough values so that you can understand what the shape of the graph is. So, what I'm going to do here is I'm going to plot y equals 3x squared for the whole number x values from minus 3 to plus 3. So, I'm going to start with just one of the easier ones. And again, if you're feeling confident, you could do this in your head, but if you're going to do it, make sure you get it right. So, for example, say that I've got x equals 0. Okay, well, y is going to be 3 multiplied by 0 squared. Well, 0 squared is just 0. 3 times 0 squared is going to be just 0 as a result. Okay, so I'm going to put in 0 as my little y coordinate here. Let's say that, for example, x were equal to 1. Then I would get y is equal to 3 multiplied by 1 squared. The thing that's being squared is the 1, because BIDMAS says we do the indices first, so we square the 1, then we multiply by the 3. So just imagine the multiplication by 3 isn't there, square the 1, multiply by 3. If you square the 1, you get 3 times 1, of course, so we get a value of 3. And then maybe just one more positive one, just very briefly. Let's imagine that I had x equals 2. Well, if x equals 2, y will be 3 multiplied by 2 squared, like that. 2 squared is 4, so that's 3 multiplied by 4. Okay, so that's going to be equal to 12. And I can mark that again on my little table. Let's imagine that I wanted to do the negative values, though. So, here we go. I'm going to put in a negative value for x. So x equals minus 1. So if x is equal to minus 1, y will be equal to 3 multiplied by, and I've got to be careful now, because I'm squaring the whole of the x. So I want to square the whole of the minus 1. And I'm putting it in brackets to really emphasize that fact. So, I'm going to write down that y is equal to 3 times, well, minus 1 squared is 1. So I actually get a plus 3 out the other end. So I put in minus 1 and I get plus 3. If I didn't have brackets around this, just to show you, let's imagine that I accidentally wrote down 3 multiplied by minus 1 squared, like that. Okay. The index comes first. I would have to, notice the way my pen top just jumped across the table there very excitingly. I would have to square the 1 first. Okay, that would give me a 1. Just going to write that in there. And then I would have to do everything else, afterwards. And I would get a different answer. I would get 3 multiplied by minus 1. And that's not what I want. So I'm squaring all of the minus 1 and multiplying by the 3. And we get this result. Minus 1 gives you a y coordinate of 3. Let's say that I had x equals minus 2. Okay, well that would give us y is equal to 3 multiplied by minus 2 squared, which is 3, and minus 2 squared is going to be equal to 4. So I get a y coordinate of 12. You may have noticed this already, but you can see this is kind of a symmetrical situation here. So, you know, minus 1 and 1 give you 3, minus 2 and 2 give you 12. This is going to be a symmetrical graph, but not all graphs will be symmetrical. Don't just make the assumption. If you can completely see that there's going to be a symmetry, great, but don't just assume the graph will be symmetrical. Okay, last two values to put in here are 3 and minus 3. Well, if I put in x is 3, I will get y is equal to 3 multiplied by minus 3 squared. I'm squaring all of the minus 3. 3 multiplied by 9, and I get 27. Oh, sorry, done that wrong, excuse me. I'm not doing minus 3. I would do 3 multiplied by just ordinary 3 squared, which is 3 times 9, which is 27. But if I did put in the minus 3, this is why I did this, I kind of was thinking ahead a little bit too much. If I did put in the minus 3, again, if you notice, the calculation looks really, really similar. The only difference is that you get a minus 3 being squared. But the answer will be the same because this is still going to give me 3 times 9, and it's still going to be equal to 27. So I'm going to put 27 down here. So I've now filled in my table of values, and even for easier graphs, even if you do this in your head, it's worthwhile having the table of values because, you know, if things go wrong, it's the working out, you can check back on it easily. If you just try and plot the points straight on and you make a mistake, you might have a lot of checking to do afterwards about which one has gone wrong, if there's an error. So the x coordinates go from minus 3 to plus 3. And I've drawn my graphs in advance to save a little bit of time, otherwise you'd have to work that out for yourself. The y coordinates go from 0 to 27. Now, if you've got graph paper or the squares in your book, you can do this very accurately. I don't have that here on this whiteboard. But what I'm going to do is I'm going to pick a scale that just fits in, and you need to do the same thing. You need to think carefully about your scale to make sure it fits in, and also not just fits in, but is big enough to make your graph clear and visible. So I'm going to choose 5, 10, 15, 20, 25, and 30 for this graph. But again, it depends. It depends on the graph and the space you're trying to fill and the particular graph you're plotting. Okay, so first of all, what I'm going to do is I'm going to plot these points. So minus 3 goes up to 27. So that's about there. I'm going to mark a small cross. Minus 2 goes to 12. Well, that's about there, more or less. Minus 1 is going to go to 3. Okay, that's about there. There's 0, 0. 1, 3, 2, 12, and then 3, 27. Like that. Right. So I'm then going to join these with a smooth curve. So it's not going to be like some kind of jagged curve that goes straight line, straight line, straight line. It's going to be a smooth curve all the way through them. So this can be difficult. Sometimes you need to rub out what you've done and start again, which is why you should use a pencil for this kind of work, so that you can adjust it. Okay, well that's not perfect, because it's not a great writing surface, but it's good enough. So you can see you get this kind of, it's almost like a bit of a bowl shape. And again, when you do a more complicated graph, it's a good idea, especially if you're drawing lots of graphs, just to label it like that. Okay, so that's it. I've done my curved graph. I can see its shape. I don't know what goes on outside that range, but you can imagine, you can guess it's probably going to go up this way and up this way. And actually that is what's going to happen, but I don't know that, so I don't need to do that on this particular version of the graph. I can just leave those bits out, like so. Okay, so there's a task for you to do that involves drawing some graphs like these. It's not too difficult, and I don't mind if you, again, just make a table of values and quickly work out the values that go in in your head. But if you're going to do that, get it right. If you're in doubt, slow down and take your time. When you draw your curve, it will be a smooth curve, something not unlike this. If you find that you've got some points and then your graph accidentally suddenly jags out in all sorts of directions, well, at this stage, you're going to be wrong. Something is wrong with that graph. So you would need to go back and check your points to make sure that they are all correct, which is where a table of values comes in very handy. Finally, as you will see on the worksheet, I'm going to want you to check your graphs in Desmos to make sure that they look like they make sense. And we're going to use Desmos in the future again, as I said before, for a little bit more kind of exploration of complicated graphs. Okay, so now you want to move on to take a look at the worksheet.